Okay, so let's look at number 23 together. I thought I'd make a video of this just in case somebody needs to go back. We'll probably end up working this one in class also, but it wouldn't hurt to have a video. You're holding one of the tethers attached to a giant character balloon in a parade, okay? So your hand is going to be this little red dot that I'm going to make. Well, it's not turning out red, but make a little red dot there. It's 3 feet off the ground, okay? And then the height of the whole, the figure. Now that height, they're measuring that from the top of the figure down to the ground, okay? So they're going all the way down here to the ground. That's the H that we see in the figure. And then they talk about the length of the string. They call it L. I'm trying to make a cursive L, but it's not doing great. Okay. Before the start of the parade, the balloon is upright, and the bottom it is floating approximately 20 feet above ground level. So now this figure is not drawn to scale, and they tell you that because if your hand's here, let's say the bottom of the figure is right here, and they say that's like 20 feet off the ground, okay? You stand approximately 100 feet ahead of the balloon, so if you're here and the balloon's here, this is 100 feet, and they want to know the length of the tether you'll be holding while walking, okay? So if you look, there's a right triangle going on here. Let's kind of draw it. I'll draw it in the figure. There's one right triangle. It would kind of look like this. Again, I'm going to come off to the side just because this figure can get crazy and it's not a very big page to work with. If the whole figure is 20 feet off the ground, so if we're measuring from the ground, you know, your balloon, maybe the bottom of it's here. I'll mark it like here's the bottom of it, and the distance from here to here is 20, okay? Now, actually, there's another little bit of a 3 feet going on. Oh, I shouldn't have drawn that line. Let me try it again. Let's see if I can make it here. You know, there's this little 3 feet piece, but then the whole piece from here to here is 20, okay? And the rest of this is the height. So if I want to kind of describe that height here, it's going to be, let's figure out what else we've got in this right triangle. There's also, we have an angle, that's one of the things that they want to know is what's the angle, if you look, or maybe they don't ask us for it, but we're going to have to find it. Oh, they do want the angle. The angle from you to the top of the balloon. And remember in this diagram that I've drawn over here to the side, your hand's right here. So the other thing they told us that this is 100 feet right here. Again, this is my L. And I know, again, that this is 3 feet. My hand is 3 feet off the ground. So find the length of the tether. Well, I could use the Pythagorean theorem here. I could say the length squared. Let's look at this right here. Just this triangle. Not including from your hand to the ground. So this would be like 17 right here. If I were to describe the whole height would be the height from here to here where I drew the dots is h, but then there's 17 more because remember you're off the ground, your hand's off the ground 3 feet. So I could say, well, L squared, the hypotenuse squared, is equal to 100 squared plus that h plus 17 squared. That's the way I'm going to write it. Okay. So I could solve that. If I square root both sides, L is the square root of basically 10,000. And then remember this h plus 17 squared is h squared. It's not h squared plus 17 squared. It's h squared plus 34h. And then 17 squared would be 289. So now I could clean that up a little bit because 10,000 plus 289 would be 10,289. So I could say that's the square root of h squared plus 34h plus 10,289, okay? Now, they just wanted, I know it's hard to read that, but hopefully you listen to the words. Unfortunately, this app crashes. If I try to go back and erase this number here, I'll try to write it better, is 10,000. It's a comma. It doesn't pick up a lot of what I write. Well, 10,289. That's the expression they wanted for part A. We can't really find it exactly because we don't know how tall the balloon is. So now let's go to part B. I'll work again in black over here. Part B says find an expression from the angle of elevation from theta from U to the top of the balloon. Okay, so again, what we're going to do is we're going to have to, let's see, you're here. So this is the angle we want. So they want to know, let's see, what do we have? We don't have a lot of information. We do know that this side right here, this 100, if I just draw this little triangle here and look at it, theta is the dot I'm going to put there. It's that little angle. This is 100. And I do know that the length is L, so I could say, well, the cosine would be the adjacent over the hypotenuse. So I could use the cosine function there because the adjacent side is 100 and the hypotenuse is L, so I could come up with that for an expression. Now, if they wanted theta in terms of something else, if they want to solve for theta, theta would be the arc cosine, or you could write arc cos, or you could write cos to the, write it like that 100 over L. Either one of those would be an expression that would describe the angle. And again, we don't have a height, so we can't really find the length unless they tell us some more information. Okay, so I'm going to move on to, I have to go to a new slide for part C, unfortunately. On 23 says, find the height of the balloon from top to bottom if the angle of elevation to the top of the balloon is 35 degrees. Okay, so we've been talking about this little right triangle. We had said this was theta, this was L, this was H plus 17, and we knew this was 100. Now they're giving us a piece of information so we can actually find the height of the balloon. And remember, the height of the balloon was, we actually had an equation going a while ago where we solved it actually for L, which is the length of the string. Okay, so for height, we're going to do something a little bit different. Let's go ahead and put our 35 degrees in, though. We can get some values here before we start making other equations. So if this theta is 35 degrees, I know then that this is 35 degrees. I'll write it over it in red. I could say, oh, okay, if I want to make an equation with the height in it, well, maybe I want to do it with length, because length is a simpler variable. It doesn't have plus 17 added onto it. Maybe that might be a little easier. I could solve for L. That would help me solve for H. It would be really kind of hard with this H plus 17 to use it. So here's what we're going to do. The cosine of 35 degrees is going to be the adjacent side, which is 100, over the length L. Now that's going to help me because if I could cross multiply, I would get basically cosine 35 degrees times L is equal to 100. If I want to know what L is, I could divide both sides by cosine 35 degrees. And L would end up being around 122. So I need to put the little wavy lines. If you put that in your calculator, that's about 122.077. Now, why is that helpful? Well, that at least gives me this side, 122.077. And if I want to know now what the height is, I could use the Pythagorean theorem because I've got a right triangle here. The math's going to get messy. 100 squared plus H plus 17 squared. Oh, this is going to be hard to read. Hopefully you're listening. Again, I can't do anything about the tools I have. I've got got what I got, and this is as fine as I can get this to write. That's going to be equal to the length squared, so 122. I'm going to put dot, dot, dot squared just because I can't fit it in anyway. I need more space. So let me go to a new slide. So I have 100 squared oh shoot, can't remember what I wrote now that I've erased it. Let me see if I can peek back at it. I may have to pause the video. Okay, I had something like this. I think I may have switched a few things around, but anyway. Okay, so h plus 17 squared is actually h squared. I have to multiply it out. Well, maybe I don't. Maybe I don't. Let me not multiply that out. Let me leave it that way. I think I wrote it h plus 17 squared. Same thing as 17 plus h squared. Now, if I multiply, I'm just going to rewrite it as h plus 17 squared. Doesn't matter, does it? If 100 squared is basically 10,000. And if I square 122.077, I'm getting about 4902. Okay, I went ahead and turned my calculator off so I could do some of that math without using up the time. Okay, I square that number. Now I'm going to subtract 10,000 from both sides. And I'm going to get h plus 17 squared is equal to, that's going to be what, 139.02. No. 14,902 minus 10,000 would be 4,902. Let me just write that in here. Again, if I use the erase still, it makes the app glitch. So sorry that it's sloppy. It's the best I can do with what I got. All right, so now I want to square root both sides because I'm trying to get the h by itself. So I get h plus 17 is equal to square root of that. I'm going to turn off the... Okay, so I did that. I put that in the calculator, and the square root of that is 70.0, let's just say 02. It's 0.01995, so it's going to round up to 0.02. So now, if I want to solve for the height, I could subtract 17 from both sides. So 70.02 minus 17 is going to give me about 53. The height is about 53.02, whatever the units were, feet high. So that would be my height. They go ahead and they translate that into inches. That they say it's about 53 feet, 1/4 of an inch. I'm fine with 53.02 feet.